In this video, we're going to continue our discussion with hypothesis tests for a population mean. So let's take a look at an example. So according to the American Community Survey, the mean travel time to work in Collin County, Texas in 2019 was 29 3/10 minutes. The Department of Transportation reprogrammed all traffic lights in Collin County in an attempt to reduce travel time. To determine if there's enough evidence that the travel time has decreased as a result of the reprogramming, the Department of Transportation obtains a simple random sample of 2,500 commuters, record their travel time to work, and find a sample mean of 29 minutes with a standard deviation of 8 5/10 minutes. Does this result suggest that travel time has decreased at alpha equal to 0.05 level of significance? You can assume the requirements have been met here. So first of all, what do we have? We have one population with a mean. It's asking for hypothesis testing. Now, you can assume the requirements have been met here. I don't need to write out all of the conditions. So now let's go straight to the null and alternative hypothesis. Well, the null would be this. Now, the alternative, look for key words. Here at this stage, we're talking about decreasing. So here, this would be my alternative hypothesis. Again, don't forget unit of measurements. Okay, so for us then, this is going to be a t-test. It'll be stats, comma, the mean, 29 3/10, comma, the sample mean, 29, comma, sample standard deviation, comma, sample size, and then this. All right, so I will show you how to put this into the calculator one more time now. Okay, go to stat, tests. We'll go to t-test, that's number 2. So again, we're going to highlight stats, hit enter. So the population mean, 29 3/10, hit enter. The sample mean, 29, hit enter. Sample standard deviation, 8 5/10, hit enter. N is 2,500. And then we want to highlight less than use of 0. Highlight calculate, hit enter. So the p-value to 4 decimal places is 0.0389. So let's go put that on our paper now. So here's the p-value. So again, we will compare the p-value to the error, which is 0.05. Yes, this decimal is less than 5/100, so we will reject the null hypothesis. And here's how we're going to write the conclusion in the context of this problem. There seems to be sufficient evidence at the alpha equal to 0.05 level of significance to conclude the mean travel time has decreased since the reprogramming of lights. Okay, so reporting the p-value or the test statistic value when presenting the results of a hypothesis test, stating the p-value or the value of the test statistic. Don't just state whether or not the null hypothesis is going to be rejected. When a result has a small p-value, aka the p-value is less than alpha, we say that it is statistically significant. In common usage, the word significant means important. It is therefore tempting to think that statistically significant results must always be important. That is certainly not going to be the case. Sometimes statistically significant results do not have any practical importance. This idea of practical significance refers to the idea that while small differences between the statistic and parameter stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. In other words, when a result is statistically significant, we can only conclude that the true value of the parameter is different from the value of the null hypothesis. We cannot conclude that the difference is large enough to be important or for us to care. So refer to the previous example. Suppose the mayor now writes a report stating that the reprogramming of lights resulted in a large decrease in mean travel time. Explain why the mayor is not interpreting the results correctly. Well, clearly we saw this p-value is less than the error, so it's statistically significant. I'm going to write that now. But it's not practically significant because the time is only decreased by 0.3 of a minute, or 18 seconds. Big deal. Not a real big concern. So I'm going to write the rest of this out now. Okay, last example. So in 2001, the mean household expenditures for energy was $1,493, according to data from the U.S. Energy Information Administration. The economists wanted to know whether this amount has changed significantly from its 2001 level. In a random sample of 35 households, he finds that the mean expenditures in 2001 dollars for energy during the most recent year to be $1,618 with a standard deviation of $321. Construct a 95% confidence interval about the mean energy expenditure. What does the interval apply? You can assume the conditions have been met here. So again, what do we have? It's one population. There's a mean. And this time around, it is asking for a confidence interval. So in this particular case, this is a T interval where it'll be 1618, comma, 321, comma, 35, comma, 95 hundredths. Where 1618 is the sample mean, 321 is the sample standard deviation, 35 is the number in the sample, and then the percent confidence as a decimal. Okay, so let me show you again how to put this into the calculator. Okay, so how do we put this in the calculator? Hit Stat, highlight Tests, and we're going to go down to number 8, which is T interval. So it's going to be Stats. The mean is 1618. Hit Enter. Standard deviation 321. Hit Enter. N is 35. Confidence level is 0.95. Hit Enter, highlight, calculate, and hit Enter. Now, notice there's only one decimal place. I'm going to round it to a second decimal place because we're talking about money. So let me put that on the paper now. Okay, so I put this on the paper. Again, other thing, I forgot the stats part at the very beginning, so make sure you fix that. Now, here's the question. At this particular stage, is the population mean somewhere in this interval? Well, clearly 1493 is nowhere in this particular interval. So here's how I'm going to write out the conclusion for this. Since the interval doesn't contain $1,493, there seems to be sufficient evidence to conclude that the mean household expenditures has changed from that $1,493.